I want you to do something a little uncomfortable for a moment. I want you to accept that there is probably a ninth planet in our solar system, that it is somewhere between 7 and 17 times the mass of Earth, and that we might already have its photograph, not in some future telescope archive, in data that has been sitting on a server since 1983. That is the part of this story nobody is telling you. Everyone is talking about the new observatory in Chile, the giant camera, the 10-year survey that just started a few months ago. And those things matter. But while the world has been waiting for a brand new machine to find Planet 9, a small team of astronomers in Taiwan, Japan, and Australia quietly went back and looked at decades-old infrared data, and they think they found something. This is the story I want to tell you today, not the headline, the footnote. Let me back up to the part most people get wrong about Planet 9. The hunt did not start because somebody saw something. It started because somebody noticed a pattern in things that should not have a pattern at all. Out beyond Neptune, there is a region called the Kuiper Belt, and inside it sit billions of icy fragments, left over from when our solar system was still figuring out what it wanted to be. Some of those fragments have orbits so extreme they reach almost half a light day from the sun. In 2016, two Caltech astronomers, Konstantin Batygin and Mike Brown, looked at 6 of the most extreme of these objects and noticed they were all tilted the same way, all clustered in one direction, all leaning like iron filings around a magnet you cannot see. That is the part I keep coming back to. Random orbits do not line up. Something has to be doing the lining up. And the simplest explanation, Occam's razor basically, is a planet. A big one, far enough out that it is invisible, but heavy enough that its gravity reaches back into the Kuiper Belt and braids those orbits together. Brown's team ran the numbers. The planet they predicted would weigh between 5 and 10 Earth masses, sit roughly 400 to 700 times farther from the sun than we are, and take somewhere around 15,000 years to complete a single orbit. One orbit, the Roman Empire to now 4 times over, and it would still be on its first lap. Here is where I want to push back on the standard narrative, because I think the way this story has been told for a decade has been a little misleading. When you read articles about Planet 9, almost all of them talk about searching for it in visible light, optical telescopes, reflected sunlight, and the assumption underneath that is, well, this is what astronomers do. This is how we found Neptune in 1846. This is how we found Pluto in 1930. So we point the biggest optical telescope we can build at the right patch of sky, and we wait. The problem is physics, and I do not think this gets explained enough. When sunlight bounces off a distant planet and travels back to Earth, the brightness of that reflection drops with the 4th power of the distance, quadruple the distance, and you are looking at 1/256th of the light. Planet 9, sitting at maybe 600 astronomical units, is so absurdly far out that the reflected sunlight reaching us is closer to a candle on the moon than anything you would call a glow. But here's the thing. Planet 9 is not just dark, it is also cold, somewhere between 28 and 53 degrees above absolute zero. And cold objects emit infrared light, their own infrared light. They glow in the heat their own existence produces. And that thermal glow does not fall off with the 4th power of distance. It falls off with the square, which means at 600 astronomical units, the infrared signature of Planet 9 is roughly 300 times brighter relative to its optical signature than it would be if it sat at Pluto's distance. We have been hunting a cold planet with the wrong kind of light, which brings me to a paper I want everyone to know about, because I genuinely think it is one of the most undercovered astronomy stories of the last 2 years. In April of 2025, a team led by Terry Longfan at National Tsinghua University in Taiwan published research with a deceptively boring title, A Search for Planet 9 with IRIS and Akari Data. IRIS is an American infrared satellite that surveyed the entire sky in 1983. Akari is a Japanese infrared satellite that did the same thing in 2006 and 2007. 23 years apart, both of them looking in the wavelengths where a cold, giant planet should glow. Fan's team did something almost embarrassingly simple. They asked if Planet 9 moves about 3 arc minutes per year across the sky, then between 1983 and 2006, it should have moved roughly 70 arc minutes. So if you find a faint infrared dot in the IRAS data, and then you find another faint infrared dot at exactly the right offset in the Akari data 23 years later, with the right brightness, the right color temperature, you might be looking at the same object, the same planet, just caught at 2 different moments in its absurdly slow orbit. They started with millions of sources. They filtered down to 13 pairs. After visual inspection, one survived everything. One candidate with an apparent angular shift of about 47 arc minutes, a temperature signature consistent with an ice giant somewhere between 28 and 53 Kelvin, and an estimated mass between 7 and 17 Earth masses, sitting somewhere between 5 and 700 astronomical units away. That candidate has been there, in those archives, the entire time, since before I was born, and nobody looked. And then, and this is the part that sealed it for me, a second team at the same university led by Amos Chen published a follow-up paper in June of 2025 using a different Akari catalog and a different filtering pipeline, independent method. Same kind of search. They came up with 2 candidates of their own, both sitting in the predicted distance and mass range. So now we are not talking about one paper that might be wrong. We are talking about 2 independent infrared analyses drawing from the same archive, both saying something is out there. Now, I want to address something directly, because if I were watching this video, I would be writing it in the comments already. You are going to say, Mike, 2 detections is not a planet. You are absolutely right. It is not. To prove a planetary orbit, you need at least 9 clean detections over time. And what Fan's team has is 2. They're the first to admit this. Their paper is not titled "We Found Planet 9." It is titled "We Found a Candidate Worth Following Up On." But here's what I disagree with in the dismissive coverage I have seen. People keep treating this as a fluke. They keep saying the real answer will come from Vera Rubin in Chile, the brand new optical observatory. And look, Rubin is incredible, and I will get to it. But there is a quieter story here about scientific humility that I think we are missing. A planet that has eluded the world's best telescopes for 10 years may have been hiding in plain sight in 2 old data sets, and the people who found it were not Caltech. They were a research team most of you have never heard of, looking through what amounts to an attic. Sometimes the answer is not a bigger telescope. Sometimes the answer is just looking at what you already have with new eyes. That said, the new telescope deserves its moment. The Vera C. Rubin Observatory sits 8,700 feet up Cerro Pachón in Chile. It has an 8.4 meter mirror, a focal ratio of 1.234, which, if you know optics, is genuinely ridiculous. Almost a wide-angle lens scaled up to industrial proportions, and a digital camera the size of a small car at 3.2 gigapixels, the largest astronomical camera ever built. First light was on June 23rd, 2025. Full survey operations began earlier this year, in the first weeks of 2026. What Rubin actually does is map the entire southern sky once every 3 to 4 nights for the next 10 years. It generates 20 terabytes of data per night, and it issues up to 10 million automated alerts per night within 60 seconds of detecting anything that has moved or changed brightness. Astronomer Megan Schwamb at Queen's University Belfast believes Rubin will discover roughly 37,000 new trans-Neptunian objects over its mission lifetime, about 10 times the entire current catalog. If Planet 9 is out there, sitting where Brown and Badigian have predicted, Scott Shepard at Carnegie Science estimates Rubin has somewhere between a 70 and an 80% chance of finding it. Not certainty, but the highest probability anyone has ever offered. And here is the part that gets me. Rubin and Fan's infrared candidate are not in competition. They are a check on each other. If Rubin sees a dot moving where the IRAS-AKARI candidate is supposed to be, that is the moment the textbooks change. So let me put a stake in the ground. I am going to make a prediction I want this channel to be held to. Within the next 24 months, by May, of 2028. I believe one of two things will happen. Either Vera Rubin will independently confirm a candidate moving through the predicted Planet 9 search region between 500 and 700 astronomical units out, or the IRAS-AKARI candidate will be ruled out by follow-up observations from the Dark Energy Camera in Chile. Either way, the question that has hung over our solar system for 100 years gets a real answer. If both happen, if Rubin spots it and DeCam confirms the same object the Taiwan team flagged, that is the most underrated scientific moment of the decade. A planet found, not by building a bigger machine, but by looking harder at the data we already had. Thanks for watching, and I will see you in the next one.